All right, let's roll. Again, no new stuff today. Using the theorems I showed you yesterday to some algebra problems. And don't get scared. Yes, I did have to remind you about law of sines and law of cosines. We may have to use one or both today. So I just wanted a reminder about that, even though it's been two units, so it's been a lot. All right, let's do this. Diagram 1. Find the value of x to the nearest tenth. That's what I'm going to give you. What is x, by the way? What am I looking to find? The length of a what? That's a chord. Good. What's the length? What's the line segment I put 3 on? That's a radius. If I happen to draw in another radius, how long is it going to be? Also 3. Good. And then that 2 part. All right, that's 2. Anybody see a theorem being applied right now based on the information I've given you? Anybody see a theorem we talked about yesterday? Hopefully, come on, dig deep. Mahmood. I only got one in the diagram. I haven't drawn another one in yet. No. Don't you steal my fire. When you get one of these, you can start stealing my fire. All right? Not yet. There's another theorem I'm looking for. Tammy?
I kind of forgot what it's called.
No, you didn't. Okay. You have the packet in front of you?
Oh, sorry.
Yeah, you do. You talk about it while you look for it.
Yeah, so it's like the diameter.
Yeah?
It kind of like bisects the...
No, it does.
It bisects the chord.
Thank you. Because it's what to the chord?
Perpendicular.
Thank you. Everyone see? We got it perpendicular to the chord. It bisects. So, we don't have to find the full chord, do we? We could find half of it and do what at the end? Double it, multiply it by 2. So let's not think about finding the whole chord. Maybe there's a way we could find half of it. All right, Mahmood, your show now. Go ahead. Show off to your classmates.
Same thing that we did in the last one, like 17.
Yeah, this radius isn't going to do me any good where it's drawn, but can you draw another radius in that may help you out? Darn right you can. From C to one of the ends of the chord. All right, what's the length of that segment you're drawing in? Also 3. Why, Mahmood? Thank you. There's where we needed to use it. All radii are congruent. In a circle, darn right. Not every radii exists are congruent. All right, and what are we using here? Pythag. Is it going to find me the whole chord? No, but we know the deal. We can multiply it by 2 at the end. All right, here we go. A squared, B squared equals C squared. Talk to me. Where's the 2 and the 3 going in this right triangle? 15. Where's 2 and 3 going? 21. Where's the 2 and the 3 going? Good. And where's the 3 going? Got to go in for C. That's the hypotenuse. You guys are welcome once again. Nearest 10th. I'm getting soft. Getting soft. Hey, enjoy your day. See you later. So what are we looking at? B squared equals 5. Take the square root. So that half of it, half the chord is the square root of 5. So x will be 2 times that. And then you guys can round that to the nearest tenth for me, and I'll ask somebody here in a second. Nearest tenth, what are we looking at? 23, what are we looking at? One. Meg, what are we looking at here? Thank you, 4.5. I don't think there's any units on my diagram. Nope. All right, so don't be afraid to draw in extra parts that you know the lengths of. Anybody all right with 1 before we get to a little bit tougher one? All right. Find chord X. And it's not getting bisected this time, is it? And again, I'm giving you 120 for a reason. I'm giving you 12 for a reason. Whew. Where do we go from out here? I don't want to tell you what to do either. Make you earn it. They want to throw anything out there, maybe? Paul, what's up?
Draw another radius from
Anywhere?
no, from C down to like perpendicular to X.
Okay.
A radius, a full radius. Yeah.
Okay.
Oh shoot. Never mind. I messed up.
And no, it's no big deal. Somebody tried to do the exact same thing second period. Problem is, I know you guys think about the homework problem we did, the last problem we did, and you're like, oh, I'll just do Pythag again, but here's the problem. You don't have another side, right? You know, this is 12 here, but I know nothing about this side, and I know nothing about that side, right? So maybe drawing a perpendicular line down, not the best one here. Avery?
Okay, this is like, I'm not so sure if this is gonna work. Could you draw a radius from the middle to the end of chord X?
So let's make a triangle here.
Yeah.
Everyone, let's make a triangle out of this. I got two sides. Can we finish this, please? And make a triangle here. How long is that? I just drew in, or you're drawing in as well. How long is that segment? 12. Okay. We're getting somewhere. All right, let's use your vocab. What type of triangle is that showing now? Oh, it's isosceles. All right, let's keep going. There's why? Why did I give you that? Just to fool with you? No. Jonah, why did I give it to you?
Because if you make an altitude from C down to X, then you have two 30, 60, 90 right triangles.
Where did those? I know where the 90 comes from. Where's the 30, 60 come from? And I'm making it difficult on you.
Like angle C is 120 degrees.
Okay, so stop right there. We're using a circle theorem, right? Arc measure is the same as the central angle measure. Everyone agrees? So look at what we have right here. I got 12. I got 120, and now I'm trying to find X here. Everyone all right? Why that angle is 120? Central angle is equal to its arc. That's why I gave it to you. Now, there's a couple of ways we could go here. There's actually 3 different ways we could go. We can decide on a class. Jonah's way, which is, hey, let's drop an altitude down, and now I have a 30, 60, 90, and I got to remember my rules. Double whatever this is because it's getting bisected. Fine. What other options do I have? We'll get back to his if we want to do it. Let's go. What other options do I have? What type of triangle was it? Isosceles. What's across from the congruent sides? Congruent angles. What are those angles? And this is why I gave it to you at the beginning of the period at the top of your notes. What could I use now? Thank you, Quan. What could I use? I could use law of sines right now if I wanted to. Or let's just start right from the beginning. This right here, law of cosines. Because you have all 3 sides, you could use law of cosines. So I could do 30, 60, 90. I could do law of sines, or I could do law of cosines. Class decision? Oh boy, are we going to have a vote? Okay, vote 30, 60, 90. Okay, law of sines. And we're tied. Law of cosines. Looks like cosines is the winner. Here we go. But hey, look. You guys that want to do law of sines, go. See if we get the same answer at the end. You guys that want to do 30, go. I'm not going to stop you guys and say do it this way on the test. All right, law of cosine, people. Here we go. You guys have it on your notes. A squared equals B squared plus C squared minus 2BC cosine A. Okay, we got to remember how this worked now.
The height is 286.
To the left, I plug in the side across from the angle, which is what? You law of cosine, people. X squared equals 12 squared plus 12 squared, the two sides, right? Minus 2 times 12 times 12 times the cosine of 120. And remember, you can plug, you guys that are doing law of, or ladies that are doing law of cosines, you can plug that in all at once on your calculator. I did not do it this way, so I gotta check this out.
It's 20.8.
Guys, you're getting 432? Cosines, 432, yep. And then just make sure we take the square root of both sides. And we round this to, what are we rounding? Nearest 10th, right? Holy gee, same answer I got, and I did it law of sines on my notes. 20.8, no matter how you did it. Nope. Questions? Everybody not getting 20.8 and you did it differently. Science people? What's up, Paul?
It's 41.7. You. Oh, wait.
I got it.
Never mind. I multiplied it by 2 that extra time. My bad.
You good?
Yeah, I'm all good.
Yeah, again, I'll do the teaching. Anybody else? We're all good here? Everyone's all set? We're all good? Go ahead. Turn it. Turn it. Turn it. Welcome back. There they are, everybody. Anybody not joining me in the celebration? I'm just clapping by myself. Yeah. They're coming. They're back. They are back. Yes. It has been since Unit 7, but they are back. 7. Yes, similarity. All right. Woo! Here we go. They are back. I know you're ecstatic. Let's do this. Before we even look at the givens, five ways you could do this. What are they? Got to review them. 5 ways we could complete this proof. What do you got? Feed me. Come on. Ooh. Come on, we got a Regents in 3 months. Let's go. That was painful. All right, let's do it. Prove the triangle's congruent. Circle facts and anything we have used already this year. Don't forget about those. Just don't think on the circles. All right, let's do this. We are given that the arcs are congruent. Arc AC congruent to arc CB are congruent. What else you got for me? Jonah, let's go.
Angle AOC is congruent to angle BOC.
Angle AOC, that is true, is congruent to angle COB. I used this theorem with you yesterday. What was given? What do we already know is true? Arcs. So ready? Congruent arcs imply, what did Jonah just give us? Congruent Don't even say angles. You better be putting a word there. Central angles. Whew, let's go. Come on. What else you got for me? That's true. Yes, Avery?
Radius BO is congruent to radius AO.
Oh, AO congruent to BO. Nice. Nice. In a circle. Got to have that term there. In a circle, all radii congruent. Double I. Go ahead, man. I'm shocked. Many of you just didn't spout this out right at the beginning to me. Go ahead, Mahmood. Yeah, our good old buddy Reflexive. Oh, it's been so long. OC congruent to itself. Reflexive. And in all seriousness, I do want to go over one point. I would not be able to do OA congruent to OB congruent to OC in the same line because, yes, are all three of them congruent? Yes. But notice how these two are a pair of sides and OC is a pair of sides. So I need to list them separately. Right? I need to list them separately. Reflexive. And I think we have enough to say the triangles are congruent. Now, by what method? Side, angle, side. But I want to keep challenging you. Name another method I could have used here. Because period 2 did it a different way. They didn't do side, angle, side. How else could have this been done using what other method? And you could still use what you did here. That's fine. Just what other method here could I have done, Paul?
Side.
Why? How'd you get AC and CB congruent?
They're cosine congruent.
Congruent arcs have congruent chords, right, everyone? So I could have said also AC congruent to CB and then done side. Oh. Anything you want to ask there? Come on, we just couldn't do one, right? You're hungry for another. Let's go. Oh, so many old memories are going to be brought up here. Radius OC perpendicular to chord EF. Oh, perpendicular lines, I know, form right angles back in the day, right? Look at that proof statement. Prove the angles are congruent. The angles aren't congruent unless...
Triangle.
Oh, so what's going to be at the end of this one? Yes, CPCTC. But we need the triangles congruent first. Can't do CPCTC unless triangles are congruent. So you better start getting me some parts here that are equal. And I am going to get fired up at one time or another here. It just depends on when it comes up. Give me a pair of parts up here. Need something. Jonah, go ahead.
Arc EC is congruent to arc CF.
Okay. Where are we going with that afterwards?
We can get EC congruent to CF.
Okay, hold on. Wait a second. Whoa, time out. Why are the arcs congruent?
Oh, never mind. I thought
Those aren't central angles, right?
no,
those
don't. Isn't like OC a part of a diameter? And doesn't the diameter doesn't it bisect the arc?
It does, but usually we say it bisects the what first?
Oh, yeah.
The chord, right?
Oh.
Right. You're right. I just want to make sure we haven't really talked that it bisects the arc too. We've really said it bisects the chord, which I want to stay with. Here's the thing I'm going to get fired up about. In step 2, we cannot say EW congruent to WF because a diameter bisects the chord. We can't say that. What's the theorem say? The theorem says if a diameter is perpendicular to a chord, what happens to the chord? It gets bisected. Does the theorem say the two little pieces are equal? No, it doesn't. It says the following, that OC bisects EF. I cannot say the two segments are equal based on that theorem. Diameter perpendicular to a chord bisects the chord. You cannot tell me the two individual segments are congruent because of this theorem. The theorem doesn't say that. The theorem says it bisects the chord. But you have knowledge now from the past, all year long, why now is EW congruent to WF. Act like you've been there. Come on, make me proud. Why is that true now? Oh boy. Caitlin. Definition of a bisector, like you never left. There we go. Nice. All right, that was fun. You still got to get me two parts, though. Two more parts that are congruent. Go ahead, get it. You're going to get out of the way, or you're going to go to the tough one?
No, I'm gonna get it.
All right, get it out of the way.
Angle EWC and angle FWC are right.
That wasn't the easy way I was talking about, but it's fine.
Oh.
You're good. Go ahead, keep going. Angle EWC and
FWC are right angles.
yep. Got to do that two-step process. Why are they right angles?
Perpendicular line form right angles.
You don't want to admit it, but you missed these. You've missed them. You've missed them. Wait till next year in Algebra 2 when you come crawling back here. I wish we were doing proofs, Mr. Crow. Yep, hate them now, but... And then I got to tell you they are congruent, right? All right angles congruent. And where's my missing piece? I got two pieces, two pairs congruent. Missing piece. Go ahead, Avery.
CW is congruent to CW.
Yep. Be careful. Make sure you say CW and not OC. All right. Make sure you say CW congruent to CW. Don't bring in OC. Well, what am I doing, huh? Welcome back to proofs, an 8-stepper. And I think we got enough now to say the triangles are congruent, right? Triangle EWC congruent to FWC. What method you got for me? 7? What method? Yep. And then go ahead and let it roll off the tongue. Welcome back. Circle proofs. Yes, one will be on your quiz Tuesday. One proof. Anything else we got to answer? Okay. The homework's not that bad. 1 algebra, 2 proofs. So we want you to get going at it. There's no reason to assign any more. Woo!
That's algebra. That's algebra.